Hey, curious people, welcome back. Today, we are going to be looking into a very interesting topic that is everything you need to know about eclipses and transits. So, this is the common knowledge that eclipses happen when one of the celestial body comes in between the two, right? Then we say that the light of one is blocked because of the hindrance from one celestial body. So, in a nutshell, we can say that it is interplay between three celestial bodies. For example, look here in this illustration. The moon, while orbiting the earth, comes in between the sun and the earth itself, blocking the light of sun reaching the earth, and then we say a solar eclipse has happened. In the next illustration, there is a lunar eclipse here. But just wait a second. We have two more celestial bodies or two more planets in between the Sun and Earth, somewhere around here. That is Mercury and Venus. So, why don't we see eclipses because of them? However, we see eclipse because of moon. So, what is happening? What is an eclipse? What is a transit? What is happening? Wait a second. I'll answer your question one by one. So, this is what I'm talking about, that between the sun and the earth, we have Venus and Mercury, and on the top of that, they are much bigger than moon, but still they are not able to cause eclipses. Why is it so? I think the answer is getting intuitively to you because moon is closer to us, right? However, Mercury and Venus are much farther away. Now, in astronomy, we call this concept as apparent sizes. Okay, so let's get into that. Apparent size. So, apparent size of an object actually depends upon two factors. First is the physical size of the body. For example, moon is very small as compared to Venus and Mercury. But on the top of that, moon is very, very close to the earth as compared to Venus and Mercury, which are really far away. So there are two factors here actually at the play, which is physical size and distance, which determines the apparent size of an object. For example, from earth, the apparent size of moon and sun is exactly the same. That's why moon is able to block humongous, giant sun. I mean, to give you an analogy, moon is like an ant and sun is like an elephant. So an ant is practically blocking an elephant. How is that happening? The answer is apparent sizes. You can practice this or visualize this by doing a small demonstration. For example, keep your thumb in front of your eyes and then try to bring it closer to you. And you will observe that more closer you bring your thumb, more things in the background are getting blocked. So the thumb, which is really small, is able to block a very huge person. So that is the apparent size. The apparent size of this thumb depends upon your, from which position you are viewing it and how far away it is from you. So that is one concept we use in astronomy a lot: apparent size, apparent magnitude. But for now, I guess you know the answer. That's why moon is able to block the sun, but Mercury and Venus don't because they are farther away. Great. If that is clear, I would like to show you some demonstration. Then what do they do? If Venus and Mercury do not block the sun or do not cause eclipses, then what do? They actually do transits. Here, Mercury and Venus make transits, and this is how it looks like literally a mole on the face, just like I have one. This is how it looks like. So, this picture on the top, this is Venus transit. This has been taken during a Venus transit. So, it looks like a small black dot in the front of solar disk. A very interesting and quick fact about Venus transit is that the Venus transit, it actually happens in pair. So two Venus transit happens over a century. In 115 years, two Venus transit happens in the duration of 8 years. So the last Venus transit was observed in 2004 and 2012. So the next Venus transit, if you want to observe it, would be in 2117 and 2125. So, my dear friends, if you have missed this one in 2012, chances that you are not going to observe it in your life again. But don't lose your heart. It's okay. We can observe the transit in Mercury. For example, the picture right down here. This is for a Mercury transit. So you can see it's a composite image. Lots of images have been superimposed one upon the other, and you can see this dot moving across the solar disk. So this is small Mercury in front of the solar disk, and you can trace its movement. These events are extremely rare, and they take somewhere around 6 to 7.5 hours to cross the entire solar disk. So these events are rare, and they are extremely beautiful to observe. But be cautious. Do not look at the sun directly because you can harm your eyes. You can burn your retina. So be cautious while observing these events. So the last Mercury transit was actually in 2019, and since Mercury does not have that kind of resonance, as I said, that in case of Venus, we see these transits twice every century and in the gap of 8 years. You might ask that why does that happen? This is happening precisely because of a unique resonance between the orbits of Sun and Venus. So, in the time when Sun take 8 years or 8 rotations around the Sun, Venus takes 13 rotations or 13 Venus years around the Sun. And these are exactly the same. So this kind of resonance matching is happening between their orbits, but nothing like that is happening in case of Mercury and Earth. So we just usually see Mercury transiting around 13 to 14 times per century. So there you go. You have a chance to observe the Mercury transit in 2032. So gear up. Now, you must be wondering what is the significance of these transits. By the way, why we are studying them. So let me tell you, they are very important. For example, this method is used to detect the exoplanets. One of the very famous NASA's mission, Kepler, it uses essentially this method, the transit method, to detect other planets on other stars, exoplanets, which is not the planet in our solar system. Okay, so in this method, as I told you, that the planet passes in front of the star. So as it passes in front of the star, it blocks very small, teeny tiny fraction of the light of that star. So what we observe is that if previously the light of the star was this much, the moment planet passes in front of it, it blocks the light, and you see this reduction in light, total light of the star. And when it goes away, we see the light back again at the maximum intensity of the maximum luminosity. So the Kepler telescope, it has a really huge legacy. It discovered over 2,600 exoplanets in the known universe, and we are still counting. We are still detecting more and more exoplanets. Turns out the planet formation is not that difficult after all. Now, switching back to eclipses. So, let's first talk about the solar eclipse. As I already told you that solar eclipse happen when the moon comes right in between the sun and earth while orbiting the earth. So solar eclipse always happen during the new moon. By the way, if you are confused about the phases of moon, I have a whole separate video on that topic, and you can click on the link in the description down below and watch my video. Now focusing on this one. So when moon during a new moon phase, it happens to come in between the sun and earth, it blocks the light of sun directly falling onto the earth, and it casts a dark shadow on the earth. Now since moon is very small as compared to earth, it casts a relatively small shadow. The dark shadow is also known as umbra, and all the regions which falls under that umbra, they experience a total solar eclipse. And it also casts a lighter shadow which is called penumbra. So all the regions where this lighter shadow is falling, they see partial solar eclipse. So the solar eclipse also have different types. Let us quickly have a look at various solar eclipses we can observe. So one is partial. This is mainly the regions which fall in penumbra or the lighter shadow, and the total and the beautiful diamond ring effect. So this happens when we fall under umbra region. Now there is another type of eclipse also, which is annular eclipse, in which most of the disk is eclipsed, it's hidden, but we can still see a ring of the sun. So why does that happen? In order to understand that, you first need to understand what is eccentricity. So, okay, in mathematics or in trigonometry, we have this concept that, for example, if you have a circular orbit, a circular orbit is perfectly circular. So we say that it has an eccentricity of 0. We denote it as E. E equals 0 is for a circular orbit. Now imagining stretching a rubber band. The more you stretch it, this circular orbit becomes more oblate or eccentric. So the maximum, so this is the maximum configuration where this band is maximally stretched and maximally in the eclipse kind of in the ellipse kind of structure. So in this situation it has the maximum eccentricity. We denote it as 1. So it is a measure of how much you can deviate from a circle, so from perfect circle to an ellipse. So it varies between 0 to 1. So you can visualize it as a factor. The more close it is to 0, you are closer to being a perfectly circular orbit. And the more close it is to 1, that means you have more elliptical orbit. So what happens is that the orbit of moon around the earth is not perfectly circular. It is a little bit uh, elliptical. And if you'll ask me the eccentricity, it is 0.05. It's not exactly 0. If it would be 0, then it would be perfectly circular. But it is non-zero, it is slightly eccentric. Slightly eccentric. Because of that, what happened is that sometimes moon is little bit closer to us and sometimes it is little bit farther away from us. So when moon is little bit farther away from us, it has less apparent size. In that situation, it is not able to block the entire disk of sun, and then we see the annular solar eclipse. I hope that you understand this concept. If you did, I have a very quick quiz question for you. So, which orbit is more eccentric? So, if you know this answer, let me know down in the comments below. The orbit of Earth around the Sun or the orbit of Moon around the Earth? Which one of them is more eccentric? I would really love if you can answer this question. Now let's move on. You know the all the concepts of the solar eclipse, the types of solar eclipse. Now you might be wondering that, okay, you said that a solar eclipse happens during a new moon. Great. Then why doesn't it happen at every new moon? Why do we see it rarely or sometimes? So, this is a very valid question, and the answer is tilt. So, the Earth's orbit and Moon's orbit are tilted with respect to each other by 5 degrees. Here in this figure, you can see that. So, this is the orbit of Moon, the orbital plane of Moon, and this one right here is the orbital plane of Earth. Now, these two are inclined to each other by 5 degrees. Because of this tilt, what can happen is that here, if that is the configuration during a new moon, sometimes moon could be too high to be able to eclipse the sun. only in certain situation when the tilt and the orbit and everything is perfectly aligned. That's why we have this idiom like astronomical event. That's a rare event or once in a while event. So that's why this idiom comes into the picture. So this uh, happens very rarely, that everything is just perfectly aligned, and uh, the moon is not high enough, moon is lower enough to cause the solar eclipse. This happens during the nodal phases. So, lunar nodes. At lunar nodes, we typically observe the solar eclipse, and if the moon is behind, we see a lunar eclipse. So, that's why it only occurs during a particular configuration. That's why you do not observe a solar or lunar eclipse each new moon or each full moon, respectively. Now as I already warned you, don't try to observe the eclipse, solar eclipse and the transits with your naked eye, because it could be extremely harmful for your retina. So always protect your eyes with proper equipment like sun goggles, which are designed to observe these beautiful astronomical events. Now let's talk about lunar eclipses. So, a lunar eclipse is when the moon is behind the earth and earth is blocking the light, or earth is casting the shadow on the moon. Now here earth is huge, humongous as compared to moon. So it casts a bigger shadow. That's why solar eclipse is a local phenomena. It is observed only at those places where umbra is falling, but lunar eclipse is pretty global phenomena. If you are towards one side of the hemisphere where there is night, on the earth you can observe lunar eclipse everywhere. So it is not a local phenomena like the solar eclipse. Okay, so that was the first point I wanted to make, and here again it happens every full moon. So full moon is a requirement. It happens always at the full moon, but just the alignment of the orbit has to be correct in order for this to happen. Okay, now when moon get eclipsed by the earth, we see moon something like this, and we also call it a red moon or a blood moon, because it does appear as if someone has put a lot of blood on the moon's disk. So why does that happen? Why we don't see entirely dark moon, and why do we see the red color at all? If it is eclipsed, it should not be visible, right? So the reason is because earth has an atmosphere. It has a lot of gases. It is holding a lot of gases. Now some of the light from the sun is able to refract, or is able to bend through the atmosphere and reach the moon. And in most cases, the light with higher wavelength, which are like red, orange, all these lights. So that's why we see the moon bathed with red and orangish hue, because of the refraction, basically. And another point which I would like to mention here is that it is completely safe to observe lunar eclipses with your naked eye, because not you are not observing the source here, right? You are observing the projection of the source on a screen. So it is completely safe to observe a lunar eclipse with your naked eyes. So now let's talk about various types of lunar eclipses. So we have three main types. So one is total, as we see if the moon is here. Look here. If the moon is falling in the dark shadow or the umbra region, we call it a total lunar eclipse. Now, if moon is falling somewhere in the lighter shadow region or the penumbra region, we call it penumbral eclipse. And if the moon is falling somewhere in between these regions, then we see a partial lunar eclipse. The moon again has three types. Among these three, the most difficult one to observe actually is penumbral lunar eclipse. So here is an image. It is again a composite image. You cannot identify actually if the penumbral eclipse is happening with your naked eye. You need sophisticated astronomical instruments or telescopes in order to observe it, because you are anyways going to see the moon, but what you're going to observe is that its brightness is going to get decreased. So that is pretty hard for our eyes to detect. So this is a composite image in which this half of the moon is, joined on the top of other half. So during a penumbral eclipse here, the moon is seen darker as compared to when it is not during a penumbral eclipse. So that's why it's really difficult to distinguish between the two. Now, you have already seen a total solar eclipse. What about this one? What do you think? What eclipse is this one? Is it a total or a partial? So the answer, this is a tricky one. This is actually a partial lunar eclipse. Look here, you can see a very tiny sliver of the moon still appearing. So not all of the moon is eclipsed here, but almost 97% of it is eclipsed. And I just put this figure for aesthetic reasons. This looks so beautiful. You can see the moon bathes in the red orange hue. So this one is a partial lunar eclipse, very close to the total lunar eclipse. So that was all. I hope you get all the concepts. And I have actually made a video. You can create these eclipses right sitting at your home by using a light source. For example, you can take a torch, by using a coin, which can act as a eclipsing celestial body like the moon, and then you can take a screen to project upon, which can act as earth. So by tricking these three objects into various positions, you can observe the eclipse and transits uh, in your room, in a dark room. So I hope you enjoyed this video. I will leave you with this beautiful compilation which I did at my home using the torch and coin. Hello everyone. Today I'm going to demonstrate you an eclipse with the help of a torch and a coin right here. Observe, this torch is going to be the source like the sun, and the coin is going to be the transiting object like the moon, and the screen right here is going to act like earth. So just focus on the coin right here. Here, the coin. Since the coin represents other celestial body, so the farther away it is from the light source, the farther away it is, it's gonna look smaller and smaller. And the more closer it is, that's the apparent size, the more closer it is gonna look bigger and bigger, and it's gonna obscure more and more light. So I first showed you the transits like this. That right here is a transit event like this. Now I will show you eclipse. So now the coin is gonna come in front of the torch, and you will see torchlight getting eclipsed. So this is something like a partial solar eclipse and the full solar eclipse like that, and annular eclipse. An annular eclipse is gonna look like that. You can see the disk of the sun illuminated from the sides, right, where the moon is not able to perfectly cover it. You can see an annular ring. So that is an annular eclipse, and it is, as it goes away, you can see a partially cast shadow as in the partial eclipse, and then you see the full sun. So you can see it with the help of a torch and a coin. Eclipse. And it's gone. If you like my video, give me a thumbs up and follow my channel for more such cool content. I will see you next time soon with again a new and exciting topic.